In today's discussion topic, we'll be addressing the time dependence of performing the characterization with instruments we previously mentioned. This is most important for X-ray powder diffraction, thermal gravimetric analysis, and differential scanning calorimetry. When performing a polymorph screening, the majority of samples come from a suspension, and there are several ways to isolate the solids for further analysis. Two common methods are centrifugation and vacuum filtration. The method in which the sample is isolated and the time it takes to characterize the sample may have an impact on the results. If a sample is solvated and left to air dry for more than 1 day, or the sample is isolated by aggressive vacuum filtration, typically, all of the stoichiometric solvent will leave the lattice, which may conceal the true phase origin of the sample. The same philosophy applies to anhydrate-hydrate pairs, but is more dependent on the relative humidity of the lab. It is always important to look deeply at your results and monitor for patterns. For example, if in a polymorph screening, you always obtain a specific polymorph in only ethanol, and the characterization data suggests it is anhydrous, this may require further investigation. What may have happened is that the true phase origin of this form is an ethanol solvate, but once isolated, the form quickly desolvated and was not captured by thermal characterization. So, if we encounter a situation like this, what can be done? For X-ray powder diffraction, it is critical to collect the results with a wet sample, typically called a wet cake. For organic solvents, they may quickly evaporate from the sample before it can be analyzed. Fortunately, there are several thin film products on the market that do not diffract X-rays. This means we can load a wet sample on the sample holder, cover it with the film to retain the crystallization solvent, and reliably collect the data of the wet cake. To reinforce our hypothesis that this form is quickly desolvating, we can remove the thin film to dry our sample, recharacterize the sample, and monitor the difference in diffraction peaks comparing wet cake to dry cake. For TGA and DSC, the time dependence control can be more difficult. The sample must be dry before characterization because residual solvent from the wet sample may skew the results. One strategy that may work is to centrifuge your sample, isolate the solids, and allow it to air dry at ambient conditions until it is a free-flowing powder. For organic solvents, this may only take a few minutes, so it is important to continuously monitor your sample so that it can be immediately prepared for characterization once it is ready. In conclusion, the time dependency for when samples are analyzed can lead to differing results, conclusions, and recommendation. In general, if you see anything atypical in your polymorph landscape, it is time to take a step back and investigate further. Thank you for joining us, and we look forward to seeing you in our next episode.